we develop haptic gloves that are able to both track movements of the user hand during an interaction with a virtual environment in virtual reality, extended reality, mixed reality, or in general, extended reality applications. And these gloves can track movements of the user fingers, integrating sensors that are inertial sensors, optical sensors, and so on, with reaching a very high precision during the tracking. But most important, we can provide haptic feedback during the interaction. So when you grasp an object, when you touch a surface in the virtual environment, you can feel this object or this surface in terms of forces, textures, and thermal feedback too. So we can provide forces, so when you grasp the object, as in reality, you feel the consistency of this object and the contact force you are applying on this object during the interaction. Then the texture rendering is done thanks to the TDK technology, and in particular to the power-up actuator, can render surface properties of the object, like distinguishing between wooden or plastic or metal parts in the environment or in the object itself. And then on top of it, we can also provide thermal feedback, which is really unique on the market. We can provide hot and cold sensations from 18 to 42 Celsius degrees. And typically we integrate these devices into applications devoted to training, industrial safety, medical training, but also marketing activations, entertainment, virtual prototyping, design of new products, where designers can exchange from two different parts of the world, not only the visual components of the objects they are working on, but also the tactile components. This is what we get inside the thimble. It's a combination of sensors and actuators. In particular, sensors are used to track and to understand the position of each finger on the space with respect to the palm or to the wrist of the user. And then the combination of three actuators integrating a force actuator, a power-up for texture rendering or vibration rendering in general, and then a thermal module for the hot and cold sensation rendering. That's the core, and it's integrated in each thimble and in the palm contact point that we have on the Touch Diver Pro. So in this moment, Giovanni is touching a virtual texture. You don't see anything here, but there is a virtual plate with a specific material that we can render thanks to the power-up actuator from TDK that is integrated into each contact point, and let Giovanni feel the surface properties of those plates. And we can now simulate leather, marble, plastic, metal, any kind of material. Then vai sul the drill. Then the same actuator can be used also to render vibrations that are coming from a machinery, for instance. Now he's using a drill for a specific operation, simulating like a training, or in VR or AR, and during this operation, the drill machinery is provided through vibration and gives the feedback to the user. For instance, understanding when the screw reaches the right position, or the tool is properly used. On top of it, he can feel forces when he grasps objects that are not provided by vibration, but by another actuator that can render constant force that is up to 5 Newton per each thimble. So he can grasp any kind of object we have on the scene. And then now, finally, we have the temperature rendering. So now there is this airflow which is cold, and Giovanni can actually feel cold on his hand. And at the same time, there is the fire here, and you can feel hot sensation, 18 to 42 Celsius degrees. And the contact point are 5 and the palm 2. So 1 per finger pad and the palm 2. And this is typically used, for instance, in safety training or in industrial training, when you need to know that a particular part of the system can't be touched, for instance, because it's too hot, but also for marketing purposes and any kind of consumer applications.